Hello YouTube, my name is Daniel and welcome back to another video. This video is the second in our Pokédex app series. So in the first video I introduced the project and set up the package structure and all of the res files such as the layouts and the fonts. In this video we're going to go ahead and create our Retrofit instance to handle our API requests, our database instance to handle our database, our repository for fetching data from the API and the database, our model files, which will be Kotlin data classes, which will hold the values of the data that we are fetching from the API. And we'll also set up our utilities such as the image utils and the constants. Before I begin, make sure you also have all the dependencies that are required for this project. So these can be found in the build.gradle files. So first we have the project Gradle here. So make sure you have these plugins. Make sure everything here is exactly the same as what I have in the project. And make sure you have all of these dependencies and make sure you're fully synced up and everything is running okay. In the project Gradle, make sure you have these variables set up here with all the different versions and also these dependencies underneath here as well. So getting back to the app, the first thing we're going to build is our Utills, and the first thing will be our constants file. Our constants file will be an object, and this will hold some values that we will use in our API and also our repository. We're just going to have two constant values, the first one being our base URL, and this will be used in our Retrofit instance, and that is going to be https poke api.co and then just a slash at the end. We are then going to have a int value which will be used for caching, and that will just be called cache, and we are going to set this to 300,000. And that is 5 minutes in milliseconds, and this is the value we'll be using for our cache. So if our data has been stale for 5 minutes, we will then fetch from the API and then store that data in our database. Next, I'm going to set up the image utils. This is again going to be a Kotlin object. So this is going to have three functions. The first one is going to be called load image. And that is going to take a image view and a URL, which will be a string. And we are going to use glide to load our images into our image views. This is an external library, and we can just simply pass it a URL and we'll be able to load that image with the URL into the image view. So we just need to import glide and then pass in the context, which we can get from the image view, and then we want to load the URL and override the width and height, and there's going to be target dot size underscore original, and the same for the width. Then the placeholder will be r.drawable placeholder, and we just need to import the resources. So r.drawable placeholder image, and this will be the same for the error image. This will just be error. And to get rid of this syntax highlighting, we can just put into image view, and that should take that away. And we also are going to use a discache strategy, and that will be discache resource. So this is going to cache the resource for the placeholder. let's sort these out here. And then we should just be able to import. There we go. So now these have been fully imported. That is the first function. The second function is going to be called load image drawable, and this is going to be used for loading a drawable into our image view. And that is going to take an image view and a drawable, which will be a int value. We can copy and paste this function here, and we're going to load the drawable instead. And that is the second function. The last function is going to be a function used to set the margins. And this is just a helper function so that we can set the margins easily with just using one method, because on most views you have to do set margin top, set margin bottom, etc. With this we can just use one method, and we need to pass in a view and then a left value for the margin left and a top value for the margin top. And we just need to import view. And we need to have a little if check for if view dot layout params is margin layout params. And then we need a variable. So val layout params equals view dot layout params as margin layout params, and then we can set our margins. And for the other two, we're just going to leave them as 0, because that's what we're only going to use in this app. And then we need to call view.requestLayout. And that is it for the image utils. And then we have our class for our dependency injection, and this is going to be called our application class. And the name of this will be Hilt Android app. And this is going to extend application. And we also need to annotate this with @Hilt Android app. And this will be the first class to run in our app. And this is just telling Android Studio that we are running Hilt, and this will be able to load our dependencies once we have declared them in our app module. So once we've added this file here, we need to go into our manifest and change the name of our application, so Android name, and we can use util.hilt Android app. Okay, we've got a warning here saying it must be public, and I think that is because this should actually be a class and not a object. So let's see if that's fixed it. And that's made the error go away. Next, in our utils, we are going to create a resource class, and this is used as a wrapper for when we're fetching data from our API. And this will be a sealed class. And this is going to take a generic type here. So we add this T symbol. And then the values for this will be data, which will use that generic. And this could be null, and a message, which is a nullable string. And then we've got a few classes inside here. The first one is class success, and we pass in the generic t. The value for this will be data, and it will not be nullable. And this will return a resource with that data and a null message. And then we have 4 of these which are a bit similar. First we have error, then we have loading, and then we have expired. And the reason we're using this class is for when our data gets delivered back to our UI, it will be wrapped in this resource wrapper, and we can tell whether it was a successful response or whether there was an error, and then we can update the UI accordingly. So if it was successful, we can then show that data in a list view. If there was an error, we can then show a toast message. So for the error, there's going to be no data, and we will just have a message. And then we can put the data here as null. Loading, again, just these 3 below will just have a message. These 2 below will just have a message and no data. So for error, we're just going to have a message and no data. Then for loading, we will again just have a message. And for expired, we will have both the message and the data. And this is used if the cache is expired. And finally, we have a single live event class. And this is going to be used in our view models. So if we have an event that we need to, let's say, show a toast message for or a dialogue, we will use a single live event. And this live event will only ever be triggered once. So you won't get this event triggered multiple times. Let's say if there's a orientation change or something like that. So this class is actually very common in Android development, and it is a free to use resource. So I'm just going to go ahead and copy and paste this from my other project and just make sure all the values get imported. And you can see here we've got the copyright details up here. Right, so that's all of the utils done. We can now move on to setting up the API. So for the API, we are going to need a new Kotlin class, which will be an interface, and I'm going to call this API interface. This will just have one function, and it will be called get Pokemon detail, and just make sure it is a suspend function. And we need to pass in a path. We can use that using the annotation at path. And the path will be ID. And we pass it in as a parameter. So ID now will be an int. And this is going to return a response with a Pokemon detail item, which we will create later. And we can import response here. And that's it for the API interface. We can now go ahead and set up our models. So firstly, we're going to have the Pokemon detail item. And this will be a data class. And now we can actually import this as well. So for most of the data classes, I am going to paste them in as they are quite long, but I will walk you through them. So we have our Pokemon detail item. We're using this entity tag here to set up our table in our room database. The table name is Pokemon details, and we have a unique value of name. So if we get a Pokemon with the same name, we will just replace it with the new values, and it won't add a duplicate Pokemon. Inside the Pokemon detail item, we have the ID, the name, the timestamp, and this is an additional value, and we use this to work out the cache. We have a list of abilities, the Pokemon stats, a list of types, and then also the sprites, which is the image. Inside the abilities, we just have the name and URL of that ability, and that is another data class which is defined down here at the bottom, so just name and URL. Then we have the Pokemon stat, which we use to set up the progress bars on the Pokemon detail card. We then have the type of the Pokemon and any sprites, such as the official artwork and also the sprite image, which is shown on the list view. Then we have a converter class, and this class is used in the room database. So firstly, when we store complex data such as JSON or data classes in a room database, it first converts it to a string, and then it uses these converters to be able to convert that data back into the needed types, such as Pokemon stat, Pokemon ability, Pokemon type, etc. So that is the Pokemon detail item. We can now go ahead and create the Pokemon list API response, and this is just for generating the initial list of Pokemon, and this will be called Pokemon list item, and this will be a data class. This isn't being stored in our database, this is just to fetch data from the API. So firstly, we need to add a serialized name property, and these are the values that we want to fetch from the API JSON body. So the first one is called count, and that is going to be a int, and we can paste this a few times as well. The second one will be next, and there's going to be a string. The serialized name is next for this. Then we have previous, which is also going to be a string. Previous. And then we have results, which is going to be a list of Pokemon results, which is another class which we will create under this one. So data class Pokemon result, and that is just going to take a name, which will be a string, and a URL, which is also a string. That is it for the Pokemon list item, and now we can create our custom Pokemon list item. So the reason we're creating a custom item is the list response from the API doesn't actually contain any images. So we have to first fetch the list and then fetch the details for the Pokemon, and then we map this to a custom list item which has the image and some other details that we can share in the list, such as the Pokemon type. This is much more easier and less resource intensive than sending the whole Pokemon detail item throughout the app and in all of our list views, when we can just have a smaller data model. So under model, we want to right click and select new Kotlin file, and this will be a data class called custom Pokemon list item. I'm just going to copy and paste this from my other project. and I'm just going to copy and paste this from my other project. Right, so for this we have the Pokemon name, the ID, the API ID. This is the ID that we get back from the API, and this is just an ID that we have for the Pokemon stored in our room database. We then have the image, which is a string, and these position left and position top values are random values that we create, and this is used to plot the Pokemon on the map. And then we have a type, which is used for filtering the Pokemon, and then we just have a variable to say whether it is saved or not, and if it is saved, it will then appear in our saved Pokemon list. Now that we have set up our data models, we can also set up our room database. So on our persistence package, we want to right click and select new Kotlin class /file, and the first file is going to be called Pokemon database. This will be an abstract class, and this is going to extend room database. We're going to have to put a few annotations on the top of this class as well. The first one will be at database, and then we need to pass our entities, and this is an array of classes. So our first entity will be custom Pokemon list item, and then we need to say ... class and the Pokemon detail item, then we need to pass the version, which will be 1, export schema will be false, and then we need to add our type converters, and this will be converters class. And we just need to import that. Right, now that's done, we need a function for accessing our DAO, which is our data access object, and that will be called Pokemon DAO, and this is going to return our Pokemon DAO interface. We haven't created that yet, but we will after this class is done. And then inside this class we will have a companion object, and then we need to initialize a instance, which will be private var instance Pokemon database, and this will be initialized as null. We need to annotate this with volatile, and then we have a function called getDatabase, and this will take a context, and this is going to return the instance if it is not null, or if it is null we will create a new instance of the DB. So instance, and then we're going to call synchronized, and that is going to equal room.databaseBuilder, pass in the context, and we need it to be the application context, as we want this to be available throughout our whole app, and we definitely don't want to use a context of a fragment or a different activity than the main one. And then we just need to pass in the Pokemon database class, and also give it a name, which will be Pokemon. And then we need to use this method, fall back to destructive migration, and then call .build. And then we just need to add Pokemon database as the return. And now that's done, we can go ahead and create our Pokemon DAO. So on persistence, we want to create a new Kotlin class. And this will be an interface, and this will be called Pokemon DAO. Now firstly, we need to annotate this with @DAO. And this class has quite a few methods, so I'm going to paste these in and then walk you through them. And then once we've done all the imports, we can see here all of our database methods. So firstly, search Pokemon by name, pretty self-explanatory. We're going to select star from the Pokemon table, where name is like the name that we are passing as a parameter. Now this like keyword here will search for whether a name contains anything in this string. So all of the Pokemon, if they have a name which contains any of the values in this name string value, then it will be returned. So if you use this method and you pass in a string with just like the letter A, you will get all the Pokemon that have the letter A in their name. The next one is just querying the Pokemon by type. So it's select star from Pokemon, where the type is like the type that we pass as a parameter. Then we just have get all the Pokemon, so select star. Then all of the saved Pokemon, and we're just selecting the select star from Pokemon where it is saved equals true. Then we have two insert functions, one for inserting a list of Pokemon and then a single Pokemon. Then we have the get Pokemon details where we're just searching via ID. Then we have an insert Pokemon details item. And this last method here is for the cache, and it's just getting the last stored Pokemon. So this just orders the Pokemon by ID in our database. The IDs go up in number order, so we know that the last Pokemon in this order is going to be the last Pokemon we fetched. And then we can use that to find out whether our cache is expired or not. Now we can go back to the Pokemon database and update the Pokemon DAO. And now it's got rid of that error. And the last thing we're going to do in this video is set up our repository. And the first class in here is going to be an interface, and this will be called the main repository. And this is where we're going to detail the functions that will be needed in order to create an instance of our repository class. So our repository class will be called main repository implementation, and that class will extend this interface and we'll have to implement the methods that we outline here. So the first method will be suspend fun get Pokemon list, and this is going to return a resource class that is the wrapper which we created earlier, and this is going to contain a list of custom Pokemon list item. Just make sure you get the correct import for resource. The next functions are pretty similar. This will be get Pokemon list next page, and this will be for the pagination. So get Pokemon next page. This isn't going to take any parameters. The next one is going to be called get saved Pokemon. The next one is going to be getting a Pokemon detail item. So we're going to put out get Pokemon detail, and for that we need to pass in the ID. And this will return a resource Pokemon detail item. We then have another function which is get last stored Pokemon. And that will return a custom Pokemon list item, and then save Pokemon. And this will be used for saving a Pokemon in the detail view, and that is going to take a Pokemon list item, which will be a custom Pokemon list item. Now that is it for the interface, and we can go ahead now and create the implementation class, and that will be called main repository implementation. And this is going to inherit from the main repository. And then we just need to implement the methods here. So before we can start implementing these methods, we need to update the constructor of the main repository so we have access to our API and also our database. So that will need to be put into the constructor, and we'll call it poke API, and that will be our API interface. The next one will be the poke DB, which will be our Pokemon DAO. And then as we're using Hilt, we need to annotate our constructor with @inject and type constructor there. And then we need to import. And now we can start implementing this class here. I'm just going to add a bit more space. Firstly, I'm going to add a value for our cache, and this will be a private value. And we're going to put this 5 minutes ago. And that is going to use the current time from the system. And that's going to be, and then we're going to minus the cache value. Now, to get the list of Pokemon, we need to first get all of the Pokemon in our DB and check whether we actually have any first and whether it's valid. So I'm going to call this response from DB. And in order to get that, we'll just call the pokedb.getPokemon. And now we're going to check if that response is not empty. And that means we can return this data under the resource.success. But otherwise, if the data is null, we're going to fetch the first 10 Pokemon and then add it to the list. So that is going to be called pre-seed list, and we will initialize a mutable list of custom Pokemon list item. And we want to retrieve the first 10, so we're going to create a for loop and do for I in 1 to 10. We will create an API request. So unfortunately we will have to do an API request 10 times to get all of the Pokemon, but that is just the way the API works. So we're going to call this API result equals get Pokemon detail, and we're going to pass in I for the ID. And we can do this because the IDs in the API are literally 1 all the way up to the last Pokemon. So we can pass in 1, 2, 3, 4, and we will get the necessary data for that Pokemon. Obviously the API could change, but we're just going to make the assumption that it won't. Now, once we get the API result back, we can check whether this is resource.success. And we just want to confirm if the data is not null. And we just want to confirm if the data is not null, and we can do this by using .let. So API result.data.let, and we would just cast this as new Pokemon, and then we can create a new Pokemon object. Which will be a custom Pokemon list item. The name for this will be new Pokemon.name. The image for this will be new Pokemon.sprites.frontDefault. The type will be new Pokemon.types. and we're accessing the first item here. Dot type, dot name, and then we're just going to cast that to string and just add in the question mark. So what this will do is it will try to get the value, and if not, it will just put it as an empty string. Then we have the position left, and this is just going to be random, and we can do this by using the dot random method, and we just need to pass a range, which will be 0 dot dot 1500 and then dot random. Position top will be the exact same. And we just need to add a comma at the end of this. And then the API ID will be new Pokemon.id, and then we just need to add this to the pre-seed list. And then if this API request wasn't successful, we will just return the resource.error. With a message just saying unable to retrieve items. And then once that for loop has been completed, we can just insert that list into our DB by calling pokedb.insert Pokemon list, and then pass in the pre-seed list. And then we want to read that data back from the DB and then return it to the UI. So we can just do this in one line by saying return resource.success pokedb.getPokemon. Now for the get Pokemon list next page, it is very similar to the first method, so we can copy and repaste this. And the only difference is we first want to get the last Pokemon. So this will be val last stored Pokemon. We can get that using get last stored Pokemon, which we will implement later. And then we create the next Pokemon ID, which will be last stored Pokemon dot API ID +1. And then we're going to initialize a list here. And we'll just call this Pokemon list. And then we can get rid of this if check up here. So our for loop will just change slightly. So for I in 1 to 10 will become I next Pokemon ID dot dot next Pokemon ID +9. So with this we will get the next 10 Pokemon. So this bit will stay the same, and then we just want to add the next Pokemon to the Pokemon list. We'll return the same error, and then we'll just insert into the list here, and then we can remove this response from DB, and also we just need to remove one of these brackets. Okay, so once you sort out the brackets here, this function will be fine. And that is the get Pokemon list from next page. So we get our last stored Pokemon from our DB, add a 1 to the end of the API ID, initialize a list of Pokemon, and then create a loop to fetch the next 10 Pokemon, initialize the custom Pokemon objects, add them to the list, insert the list into the DB, and then return the list. Next, for our get saved Pokemon, this will just get them straight from our DB. So we just have a DB result, which will be pokedb.getSavedPokemon. And then we're going to return it in a resource wrapper. So firstly, we're just going to check if the DB result is null or empty. Return resource.error. saved Pokemon list is empty. This will just be our message, and otherwise we just return resource.success with the DB result. And that is it for that function. Now before we do the get Pokemon detail, I'm just going to complete these functions because they're quite small. So get last stored Pokemon will just be return pokedb.get last stored Pokemon object, and save Pokemon will just be pokedb.insert Pokemon, and then the Pokemon list item as the parameter. Now before we can implement the get Pokemon detail function, we just have to create another small function to fetch the Pokemon details from the API. And that'll be called get Pokemon detail from API. And this will take the same ID and return a resource Pokemon detail item. Now as we're calling the API, we want to use a try catch to catch any exceptions, such as no internet access or host not found. And we're just going to call this exception. And then we want to call the API. So we're going to call this API result. And that will be poke API, get Pokemon detail, and then pass in the ID. This will be a suspend function because we're accessing the API. And then we're going to check if the API result is successful and if the body is not null. And if there are any issues, we will just return resource.error. And use the API result message. Now when we retrieve the details, we want to add in the timestamp of when we actually retrieved them. And this can be used to check the cache later. So we first want to initialize the new Pokemon object, which would be API result.body. And as we've already checked that it's not null, we can use this nullable operator here, so the double exclamation point. And then we can initialize the timestamp, which would be system.current milliseconds.toString. And then we can store this in our DB. So now it'll be pokedb.insert Pokemon details item, pass in the Pokemon. And then we want to read it back from the DB, and then we want to read it back from the DB and then return it. And in order to do that, we can use return resource.success, pokedb.get Pokemon details, and then just add the double exclamation mark at the end. And if we have an exception, we'll just again return a error, and then we'll just call this error retrieving items. And now we've created this function, we can then go ahead and implement the final function in this class. And then for this, we first off want to read from the DB. So now it'll be dp result, which will equal pokedb.get Pokemon details. And we just pass in the ID. And then we're going to check whether we have that Pokemon in our DB. And if we do have it in our DB, we just want to check whether the cache is valid. And if the cache value is valid, then we'll just return it straight from the DB. If not, we'll fetch it from the API. So in order to check that, we just need to access the DB result and the timestamp, and then we can convert it to a long value. by using the toLong method. And we just need to check if it is less than 5 minutes ago, which is the variable we initialized earlier. And if it is less than 5 minutes ago, it means our cache has expired. So we can return get Pokemon detail from the API and pass in the ID. Otherwise, we know the cache is sufficient, so we can return the cache, so resource success, and pass in the DB result. And otherwise, if it is null, we just need to call get Pokemon detail from the API and pass the ID. And just add return here. And that is the repository implemented. Then that will be it for this video, guys. In the next video, we'll set up our dependency injection and also begin setting up the UI for this app. If you have any questions, please post them in the comments. Please like the video.